All right, so I made a mistake in the end of that last video, and I accidentally, when I calculated the difference, I calculated the difference between the protected areas and the whole extent of Idaho, the whole state. Um, but that's not really what I wanted. What I wanted was the difference between the protected areas and the range of the moose, which is a little bit smaller than the whole state. Um, so I went back and did that again, and you'll see the correct parameters there on D2L, and that gave me this moose range not protected area. Um, and so this represents the extent of moose range that isn't covered by one of those protected area descriptions, one of those protected area categories. So the next thing I want to do is take um, this other category, moose range, and join it in with um, the existing categories for protection. And I already aggregated those just to take them from 1,000 some shapes down into 4. Um, so we're going to use the merge vector layers tool. Select my input layers. I want to select aggregated and moose range not protected area. Okay. And save this as all moose range. Save that. Okay. Go ahead and run that. And I'll pause. Okay, that didn't take long at all. Looks like it ran successfully. Let's see what we got here. Close this window. So it looks right. We've got this whole, we've got the whole area of the moose range. Let's take a look at the attribute table. Yep, it looks reasonable. So it sort of, when we merged these two vector layers, it just smashed all the attributes together. And so these first 3 fields came from the protected areas dataset. And then these 2 fields came from the state. Don't have a whole lot of meaning to us. And then these fields came from joining the whole thing together. So this is good. We've got what we want. But we don't just want all these shapes. We want to know their areas. There's a couple of ways to do that. One way that I often use is this add geometry attributes tool. It's under vector geometry. So I'll open that. All moose range. So add geometry attributes, it knows what type of geometry you're handing it. If you hand it points, it'll add X and Y coordinates. If you hand it lines, it'll add distances. And if you hand it areas, then it'll calculate area. So and you can do this in the attribute table in the field calculator too. In my experience, this approach tends to be a little bit quicker. I'll do it this way. So this is all moose range areas. Okay, save that. Works. Pause. It's running. Okay, it took about a minute to run, not too bad. Let's take a look here and see what we got. So I'm going to right click and open the attribute table. And here we go. The tool added 2 new fields. It added area and it added perimeter. And so area is in map units, so that's going to be in square meters, perimeters in meters. We're not going to do a whole lot with perimeter. I'm looking at the attribute table here. I might take the opportunity to clean it up. There's two things I want to do. Firstly, so I'm going to turn editing on. Firstly, I think I had misspoke earlier in this video when I was saying that the other area was sort of like the protected area category 0, but I had misunderstood the arrangement of the protected area numbers. So in fact, I had turned on editing here, so I can just go ahead and type in this field. It's just a data table. I'm going to call it 5 because 1 seems to be the most heavily protected and 4 seems to be the least protected. So this other area, we'll give a name just for clarity. 5 other, okay. I'm going to go ahead and save those edits. And then, actually, I want to make a couple other changes while we're at it. We have a whole bunch of fields here that we don't need. So let's just simplify our lives here. Unit name has lost its meaning. Remember, this is just the first value of all of the protected area shapes that were aggregated here. So unit name has lost its meaning. Gap status and description of gap status, those still have meaning. Season code, that's not useful. Season name is not useful. Layer, that's what layer that particular record came from when we merged, but we don't need to keep track of that. And then path, the path to the original file, that's okay, we don't need that. I'm also not going to do anything with perimeter, so I'm going to go ahead and remove those fields. Okay, save my edits. And come on. And then I'll turn editing off. Okay, so I'm pretty happy with that layer. In fact, I'm so happy with that layer that I'm going to remove just about everything I used to get there. Again, not deleting anything, just removing it from the project. Save the project from time to time. So if I go back to the attribute table, actually, I'm going to do this another way. So I right click on it, I'm going to export it, and I'm going to save features as. And what I'm trying to do is just get the data out. So it asks me what format I want to save the features as. Well, I don't want a shapefile, I don't want a geopackage, I just want the data. Remember that we brought in the point wildlife collision data from a CSV earlier, so logically we can also take this shapefile and export it back as a CSV. We're going to do exactly that. And I will call this moose. Let's call this Idaho moose range. Type range areas. Okay. Okay. And so now, oh, it loaded it. That's sort of funny. It's just a data table. I know exactly what it looks like. It looks like that. But now that it's a CSV, I can just open it in Excel. And I'm doing it that way because the first question that we're trying to answer here is just what portion of a species range falls under different designations. So we have these designations, we have these areas, we've done the spatial part of the work, and we're at the point where we don't need the GIS software to answer these questions anymore. So you could do some more math in here with Field Calculator. You could calculate the total area, then figure out what portion each one is, but I see no reason to make our life harder than it has to be. So export it as a CSV. It's just a data table. Open it in Excel or any spreadsheet program, and you can easily calculate those values. Okay, so I'm going to close that, and I'm going to remove this layer. Okay. And so the next thing I'm going to do is bring back the next thing I'm going to do before I bring back in the wildlife collision data, just since I'm going to be looking at this, might as well look good. So let's give it some symbology based on, oh, not categorized, I want graduated, based on that protected area category. So we'll say there's 5 classes. You could do it as graduated or categorized. It's quantitative data, but there really are just 5 categories. So it actually may be more correct to do it as simply categorized. And give it some sort of reasonable color ramp, classify it. Okay, we've got 1, 2, 3, 4, and 5, and then we've got all other. Okay, that's a little concerning because I think everything should be 1 through 5. Take a look at that. Oh, and this color ramp, if I want darker green to be the more protected areas, then I should invert this color ramp because 1 is the, there's invert color ramp. 1 is the most protected, 5 the least. Okay. All right, that looks reasonable. I'm going to take one more look at this attribute table. Yeah, so we really do just have 1, 2, 3, 4, and 5. So I don't know why the GIS is giving us this other category, but we won't worry about that. Great. So now I want to bring back in the point data. It's right there, roadkill Idaho.shape. Okay, whole bunch of points. And let's remember what we're trying to do. Okay, so the first question was, do all reported vehicle-animal collisions occur within the designated range, right? So for the simplest way to answer that, I might actually want to bring back my moose range data, which was moose Idaho.shape. Okay, turn off this other guy for the moment. So we want to ask the question, do all of these points fall into this shape area? And at first glance, it's obvious that they don't. So that's the simple answer right there. But of course, we're going to do a little bit more than that. What we're going to do is count points in Polygon. It's under vector analysis. And so if I right-click here and open the attribute table, I can see that there are, let's say, 55,000 features total. So how many of them are in the polygon? Well, let's find out. The polygon is just going to be moose in Idaho. The points are roadkill. Okay. I'm not doing anything fancy. I'm not weighting my count by anything, and I'm not categorizing it by anything. Not yet, anyway. And we will just output this as a temporary layer. Okay, go ahead and run that. Excellent, that's what I like to see. It took 3/4 of a second to run. So if I open the attribute table here, I see that there were 54,154 in the, oh, huh, I forgot something. I forgot a step. Let's go ahead and remove this. These are all roadkill. Logically, I want to filter this down to moose before I do anything else with it, right? This is all species. So we did this with the Highway 200 project. I'm going to filter using the form here. And I'm going to say species. I'll start typing moose. It should help me. Yeah, there we go. Moose. Species moose. What I actually want to do is get rid of everything that's not a moose. There's a number of ways to do that. One thing I could do would be select everything that is a moose, then invert the selection, then delete the resulting selection. Or I could change this contains to not contain or is not equal to. And that way it would sort of be one step. I would just select everything that isn't a moose. In this case, I don't think I've made another copy of this roadkill dataset. So in order to preserve it, I'm just going to select everything that contains. It might be better to say select everything that's equal to moose. Okay, we'll do that. Scroll down to the bottom here and click select. Then this little button down here brings me back to the table just so I can scroll around and see, yep, it's clear that there's only one right there, that the moose has been selected. Okay, so I'm going to close this table. Now we can see the selected points, they sort of show up. And so now instead of using this selection to edit this vector layer, I'm going to use it to make a new vector layer that's just the selected. So I right-clicked and went to export, save selected features as. I don't want to save them as a comma-separated value. We'll go for a shapefile there. And so this is Idaho moose collisions. Okay, save that. Okay, should just take a moment. Yep, there we go. Okay, and so I'm going to remove the layer for all wildlife collisions. Okay. So now we have just the moose collisions. I'm going to go back to where I was. Overall, there are 1,307 moose collisions. So let's count the number in the polygon. Polygon is moose in Idaho. Okay, run this. Okay, it ran so quick, I didn't even think it ran. Excellent. So if I open the attribute table for count here, I can see that there are 1,293, and I think I said there were 1,307 total. So there's the answer to that second question. Not quite every vehicle-animal collision, vehicle-moose collision occurred within the moose range, but a lot of them. And, so that gives us some insight into the accuracy of this moose range definition. I would say it's probably pretty good, actually. So turn that layer off. Now if we get on to our third question, it asks, within the designated range, are the reported collisions evenly distributed between the different protected area types? And evenly distributed, you could interpret that a couple different ways. Firstly, it could just mean, are there an even number? But maybe a more insightful interpretation would be, are they distributed evenly in a spatial sense, right? Are they spatially distributed evenly across this landscape, these different protected areas? And at a glance, I'm going to have to say, for moose, I don't think so. Just the number of them that are happening up here in the panhandle, where there's not a ton of protected area, a little bit, and then not so many happening down in central Idaho here. Of course, that's probably just because there aren't a lot of roads there, but that's perhaps beyond the scope of our question. So just the same way we used the count points in Polygon tool to count the number in the total range, now we're going to use it to count the number in the different areas. So count points in Polygon. Polygon, now I'm going to use all moose range areas. because remember that has my 5 records with my 5 protected area types. Points are moose collisions. And do I need to set class here? So class comes from the points. No, I don't think I need to set class. And we will just create a temporary layer here. Once I get the layer, I might want to actually save it as a CSV again for further analysis. So go ahead and run that. Execution completed in 44 seconds. That's all right with me. And let's take a look at what we got here. Open attribute table. Okay, so we've got the number of points in each of these areas, and conveniently, this count points in areas tool also saved the other data that we're going to want. So I am going to right click on this, export it as a CSV. And this is loose collisions by area. Okay. So that concludes the GIS part of this tutorial. I might poke around at the data in Excel. I'm quite sure I don't need to give you guys a tutorial on how to use Excel, but so I might do it. Recording, so I might record it. All right, I'm going to save this project so I can come back to it, and then let's go look at this data. So moose collisions by area. Okay, open that guy. Oh, it's locked for editing. Okay, that's because it's still open in GIS. Remove that. Okay. Try to open it again. Much better success this time. Okay, Excel, by the way, Excel gets really mad at you when you save things in comma separated value CSV format. Excel wants to be fancy, and so they want you to save it in Excel format, but you can just ignore that. Okay, so the simplest way to answer this question of are these collisions proportional would be simply to divide the number of collisions by the area. So it's the equal number of points divided by area. Okay. So that's number of collisions per square meter. You know, just at a glance, I think I can do a little better than that in terms of actually having an intelligible number. So let's do, I'm going to insert a column here. Let's say area kilometers, and that is equal to the area in square meters divided by 100 squared. I have to do it that way, otherwise I get confused. Oh, sorry, how about 1,000 squared? There we go. How's that for confusion? Right, 1,000 meters in a kilometer, so 1,000 squared. Okay, good, I can do math. So now, let's say, how many collisions are there per square kilometer? That's a slightly better number. And I think I have to conclude that at least for moose, they are radically non-evenly distributed. They occur at a radically higher rate in this other category than they do in any of the other categories. And in fact, the most protected category has none whatsoever. So, you could question what the correct interpretation of this would be. I think my initial guess is that most of the people live in this other category, most of the roads are in this other category, and most of the traffic happens in this other category. All right, that is what I got for you. I do, among the many different things that I'm sort of hoping to convey, I do hope that you noticed me making some mistakes, having to go back and try something again. Very rarely do you do an analysis just perfectly one step at a time the whole way. So going back, debugging, wondering what you did, that's always a helpful process. And when you're doing that, I'll just point this out. This history tool here can be super helpful. So for example, if I wanted to run um, the difference, or well, that was a while ago. If I wanted to run the count points in Polygon tool again, I'm like, oh, when I did that step, I almost got it right, but I just switched two of the inputs, just like I actually did half an hour ago. Just double click on this and it brings the tool right back as it was when you last ran it. So you can sort of go through, just lost my window, history. You can sort of go through and see the different tools that you've run. And for me, that's a really helpful way when I get stuck, when something goes wrong, I can sort of go back and look at the steps that I've gone through. And going forward, we're going to actually take a closer look at how to some approaches for building a really robust and useful and reusable workflow for your GIS stuff. All right, thanks everyone. Let me know what goes wrong and when you get stuck. It is the world of advanced computing, so we can count on some weird errors popping up from time to time. And I'm here to help you get through them. All right, thanks.